So this is the reaction we're dealing with here, and so we're told in words what the rate law is, and we have to write an expression. So the rate is always equal to first a rate constant K multiplied by what we're given, and so we're told that this is second order nitric oxide, so concentration of NO squared for second order, and then first order in oxygen, so times the concentration of O2. That's all we're told, so that's our rate law. And so in order to find the overall order, we need to add the orders of each of the reactants. So we have second order for nitric oxide plus first order for oxygen tells us that this reaction is third order overall. Great. Now, we're asked to consider what happens if the concentration of O2 is doubled. So it's saying times 2. Well, it's first order, and so that means it's direct, like the rate is directly proportional to the concentration of O2. And so if the concentration of O2 is doubled, the rate increases by times 2. It's doubled also. Now, I'm going to erase some of these numbers here. What happens if the concentration of O2 is divided by half, so times 1/2, and the concentration of nitric oxide is doubled, so times 2. So look at the overall, let's look at NO first. So since it's times 2, but to the second order, the effect on the rate is that it's going to be times 4. Now, as we had earlier, since oxygen is first order, and we reduce the concentration by 1/2, then the rate is going to be multiplied by 1/2. So what we're really saying is the rate, right here in green, is going to be increased by 4 times because of the change in NO, but multiplied by 1/2, reduced by 2 because of the change in O2. And so that's going to tell us that the reaction is going to become 2 times faster, 4 times 1/2.